Okay, now we want to look at some general theory of solving equations. And it really boils down to what I would call two ideas, but you could say there are four ideas. So suppose I start with a couple numbers, like 11 equals 11. Okay, hopefully you can't argue with that. Okay, 11 is 11. 11 is equal to 11. Now, but notice what happens if I add 5 to both sides of the equality. Okay, I get 11 plus 5, and my claim is that's equal to 11 plus 5. Okay, and again, I think you probably wouldn't argue with that. So if I add the same thing to both sides, I'll get 16 equals 16. Now notice, that's not the number I started with. That's okay. I'm not worrying about keeping these numbers on each side exactly the same. I am worrying about keeping the equality true. And so if I add a number to both sides of an equality, the same number, the equality is still true. Okay, so similarly, if I start with my 11 equals 11, and I subtract 3 from each side, I get 11 minus 3. And again, my claim is that's equal to 11 minus 3. And certainly 8 is equal to 8. So again, the equality stays true. But it's with different numbers now. But that's okay. Okay, so I can add, I can subtract the same amount from both sides. Now, similarly, I can multiply and divide. So if I start with 11 equals 11, and I multiply both sides by 3. Oh, go to another page here. I get 3 times 11 equals 3 times 11, and that's my claim. But again, that's easy enough to check. It's 33 equals 33. Okay, and they're the same. Okay, the right-hand side and the left-hand side changed values, but the equality is still there. Okay, so, and then finally division. 11 equals 11. Well, I picked a terrible number to divide by, or divide through, but I could divide by 2. I'll get 11 divided by 2. Again, my claim is those are equal. And 11 divided by 2 is 5.5, or 5.5. And 5.5, yes, they are equal. Okay, so that is the idea when solving equations. And so if you have something like, x plus 3 equals 7, then you see, because of that equal sign, this number is 7. This number is 7. They have to be. Now, I don't really care that this number on the left is 7. What I tend to want to do is solve this equation to get my x. But the point is that this is just 7 by some other name. And how do I know that? Well, because the right-hand side says it's 7, and I have an equality. So that's 7. Now, what I can do, though, is see, I can get smart here and say, well, if I subtract 3 from both sides, if I do that, then I got this nifty thing on the left-hand side. The 3's canceled, and I just get x. But on the right-hand side, well, I get 4. Okay, but this equality is true. Because I started with 7 equals 7. I subtracted exactly the same thing from both sides, the 3. And so when I get x equals 4, even though I didn't know what x was, I know that whatever number it is, it has to make this equality true. And so it turns out this is very easy now for me to read. And I have a number. So this says I have a number. That is equal to 4. What is it? I'm going to go with 4. Okay, see back here, I didn't know what this number was, x, so I could have written something like, I have a number plus 3 that makes or is equal to 7. Okay, well, I don't know what that number is. But down here, I know what that number is. And so, again, it's that same idea. If I have a multiplication or a division or something like that, if I have x divided by 5 is equal to 12, okay, well, again, this side's 12, this side's 12. They're equal. Okay, so I have a number when divided by 5, I get 12. Okay, well, but I don't know what that number is. But again, if I multiply both sides of my equation by 5, then I still have an equality. Okay, but 5 times 1 over 5 is just 1. So I'll get x equals 60. So x is equal to 60. Huh. Well, that's what I just wrote. Okay, but this is my equality. This is my statement. They look the same. Okay? They're really one and the same. But that is the idea in solving equations, is that we can add, subtract, multiply, or divide both sides by the same number and keep the equality true, and therefore eventually get to our unknown value x. And so, you know, that's also how we do things like, you know, suppose I have 2x equals x plus 4. Okay, now here, neither side do I know what the value is. I just know that, you know, that number is the same as that number. Okay, but once again, what I can do is I can take 2x. Now, if I subtract x from both sides, then I get the nice little thing that over on this side I get x. And on the right-hand side, well, I get x minus x, which is 0, and 4. So now I've got my solution. Okay, but you see, I don't know what x is, but I know x doesn't change. X is x, you know, it's some value that I just don't know yet. And so when I subtracted it from both sides, I didn't screw up my equality. So the only thing we can't do, okay, we can't multiply or divide both sides by 0. Okay, the issue there is that suppose I take 8, and that is definitely not equal to 5. Okay, but if I multiply both sides by 0, I end up with an equality of 0 equals 0. And you see those two things, they didn't follow from each other. Same thing as if I try to divide by 0. But of course we aren't supposed to anyway. We can't divide. We can multiply things by 0. But with these equalities it doesn't work. So if I end up multiplying both sides by 0, all bets are off. It doesn't work anymore. Okay, but that's the basic idea of solving equations. Now I can get very complicated with many, many steps, but all the steps are essentially one of these four things: add, subtract, multiply, or divide by the same number. Okay, so that's our background theory.